Solving an initial value problem. We're going to be solving the differential equation y first derivative plus 2x y squared equals 0. To do this, we're going to be needing our family of solutions, which is y equals 1 over x squared plus c, and the initial condition y of 2 equals 1/3. So the first thing we're going to be doing is trying to solve for the c value here. So we're going to bring our equation y equals 1 over x squared plus c, and we're going to be replacing our x with 2 and our y with 1/3. And doing simple algebra, we're going to be able to find that c equals -1. So now that we know that c equals -1, we can replace that right here, and we can get rid of those right there. Alright, so now the next step we're going to be doing is finding the largest interval I over which the solution of the differential equation is defined. Now to do this, we're going to be taking our equation that we just found the value of c, y equals 1 over x squared plus -1, and we're going to be finding the domain for this. Now to do this, we know that you can't have 0 in the denominator. So we're going to be finding anything that might equal 0 in the denominator. -1 equals x squared, or plus 1 equals x squared, and so x cannot equal -1 or 1. So now knowing this, we can write -infinity, -1, u, -1, 1, 1, infinity. And so this is our domain. All real numbers except -1 and 1. And so now we can take this little equation, bring it down over here next to everything else, so we don't forget it. Alright, so now our next step is the largest interval I over which the solution of the IVP, initial value problem, is defined. So to do this easily, or the most easiest way we're going to do it, is going to be to graph the solution as to be able to visualize it the best. So when we're graphing it, we're going to be graphing for this domain right here. And to do that, we know that we need -1, -1, -1, 1. And so we're going to be graphing this. So now we know that it can't equal -1 or 1. So we can draw our little asymptotes in here for visual reference on the x value. And now we're going to be graphing for -infinity to -1. So I can tell you now that -infinity to -1, the graph's going to look something to do with that. Now to prove that our graph is in this positive section right here, we can simply plug in anything between -infinity and -1. I'm going to do -2. And we can plug that into this equation right here. So y equals 1 over -2 squared plus -1. And so here y equals 1 over 4 minus 1, 3. So notice how this y value is positive, thus we're going to be in quadrant 2, the positive y value quadrant, or a positive y value quadrant. So now our next step is going to be to graph. We're going to graph 1 to infinity next. And we also know that this is going to be in our positive quadrant, again, for the same reasoning, since the square value removes the negative. And now for the third section is going to be -1 to 1. Now this is going to be in our, it's going to be below the x-axis, and it's going to span our third and fourth quadrant. Now we know that this is the case since plugging in, say, 0 into the equation is going to give us a negative value in the denominator, thus y is going to be a negative value. So now that we have graphed our domain, we're going to be plugging the point for our initial condition, y of 2 equals 1/3. So with this, we know that our x value is 2, and 1/3 is our y value, and we plot it like any other point on a Cartesian coordinate system. And we can go to here, and 1/3 there. So this point right here is going to be 2, 1/3. So now that we know that this is the interval over which our initial value is found, our initial condition is found, we know that the largest interval I over which the IVP is defined is going to be 1 to infinity. That's about infinity. And so now our solutions, or what we have found in this, is that the value of c is -1, that our domain for our x is going to be -infinity, -1, union -1, 1, union 1, infinity. And our largest interval for which the IVP is defined is going to be 1 to infinity. Please like and subscribe so I can get more and better videos out. Thank you.